going into today's presentation, I would like to take a few moments to reflect on the unprecedented and very challenging times that we currently are in. First and foremost, on behalf of Wiwynn, I would like to extend our warmest and most sincere gratitude to the thousands of medical professionals and others from the essential services who have put their very own lives at risk to save our near and dear ones and to keep the system running. A very big thank you from Wiwynn. You're all most certainly in our heavy hearts and prayers. We will prevail and this too shall pass. I'm Raghavan Venugopal. I'm Executive Director, Chief Account Executive at Wiwynn. I'm responsible for building a customer-centric organization and developing a center of excellence in different aspects of engineering: design, development, deployment, and post-deployment that is closer to our customer. And today we are going to be looking at a topic that is very close to my heart. It's about building solutions with modular design that extends all the way from the cloud to the edge. A little bit of introduction about Wiwynn as a company. Wiwynn as a company was established in 2012. It is listed on the Taiwan Stock Exchange with a ticker symbol of 6669. Our mission is to be a valued partner for customers in cloud service business. And what that means is we build, develop, design, deliver, deploy, and maintain the infrastructure that keeps the cloud running. Now, the topic that we are going to be discussing is two-pronged. One is about modular designs that is used for building solutions, and the other one is about the range of solutions that we offer from cloud to edge. The first topic is about modularity. So what is driving us towards modularity? There are many different aspects and requirements that we are hearing from our customers that is driving the design towards modularity, and some of which we discuss here. First and foremost, the time to deploy our solutions is shrinking. The second, what we continuously keep hearing is the quality of our solutions is going up. And of course, if you are in this business, we all know that the cost is also a key factor, and it continues to keep going lower. And then, the development model is going from a waterfall model to an agile development model. And what this means is there is a continuous improvement on what has been deployed and what is being developed and what is getting integrated. And then the other key aspect is about the readiness of the design itself. That, along with the time taken to deploy, the time at which the solution needs to be ready is also happening much earlier in the design cycle. And then finally, it's not about building blocks. It's about putting solutions together using all these building blocks. So it's about testing a solution versus testing just the building blocks themselves. So all of which leads to a set of conflicting requirements, which is we want to design solutions in lesser time, but higher quality, in lower cost, but being more agile, in being ready early, but building solutions. And what we believe at Wiwynn that could answer some of these conflicting requirements is modular solutions. And when we look at the architecture of our solution, we divide the architecture into major categories. The first category is the board design itself. And in the board design, we have motherboard design, PCBAs that support the solution, the system, along with the motherboard, and then the firmware that goes on all these boards, whether they are a motherboard or the PCBs. And then there is the chassis, which is the mechanical aspect of the system. and the thermal solutions that go along with that chassis. And finally, at the rack level, there is a system management that needs to be taken into account, the rack management that needs to be taken into account, and the power supply that resides either in the chassis or at the rack that needs to be accounted for as a key building block. So that's how we divide the different categories of building blocks in our system architecture. Now, getting on to the second trend, cloud to edge. We believe that the natural evolution from cloud is next to the edge. Why do we believe this? Because today we know, working very closely with service providers, that applications and workloads are hosted out of hyperscale data centers. But in the coming days, what we see is an opportunity, and where the technology trend is going is for these same workloads and some new workloads as well to reside closer to where the customer is, closer to where the application is, and closer to where the data is getting generated, which is basically at the edge sites. And in order to account for this varied needs all the way from cloud to edge, Wiwynn has several products. And first, the products that we have for the public cloud, which we have announced and which we work very closely with our OCP members, is Tioga Pass, which is a 1U, 1-node dual socket design, and also a 2U, 3-node dual socket design. And in addition to that, we also have the Project Olympus, which is again a 1U, 1-node dual socket, and also a 1U, 1-node dual socket, which is specific to a big customer that we work very closely with. And in addition to those, we also have a 4U 12-node single socket, which also has a varied version of it with AI accelerators in it. So these are all products that we cater specifically to our cloud segment. When we get to the edge, we also have very exciting products like the EP100, which is a 3U 5-node design, and which is completely open, and it's an open edge platform that is catered specifically towards edge and AI. And we also have the ES200, which is a 1U 1-node dual socket. It is a short depth server, because we do understand the needs of the edge products to be of shorter depth and fit into racks of much shorter depths, and also being able to be mounted if the need be in a central office or any other edge locations. And then we also have the 1U 2-node dual socket, which is a dense server. So all these three products together, we believe, fits the varied needs of the edge arena. And then, we have this EP100, which I also want to stress a little bit more about the diversity, because we do, believe that this is an all-in-one edge platform. And we believe that because it is centralized and it's also distributed. It could be a core. It could also be an MEC on the edge application. So we do believe truly that this is an all-in-one platform that we have built, specifically catering to edge. And then, when we go in about, we discussed about the modular design. We discussed about our categories that we use towards modular design, and what are the benefits that we drive because of this modularity. The first and foremost benefit is choice. So we want to make sure that our customers have multiple choices that accounts for their diverse workloads, and they are not locked in to a particular vendor's platform. The second is about agility. Agility has several characteristics about the elasticity, about how quickly we can respond, about how predictable our delivery times are, and how fast we can deploy. All of that are benefits that we believe that a modular design provides as far as agility goes. And when it comes to quality, it is always about higher MTBF and lesser downtime for our solution, and the solution readiness being available at a much earlier time during the design cycle. So all of that is captured under the quality aspect of our modular designs. And then, last but not the least, it's about cost. So you have to have a cost that is lower in to develop, lower CapEx and lower OpEx, because we have an improved efficiency with our modular designs. So that, in a nutshell, are all the benefits that our modular design provides for all of our solutions that range all the way from cloud to edge. So some of our key considerations for modular design. So first and foremost, when we considered to build the EP100 and ES200, we had to look at the space constraint. We had to look at the environmental conditions that are different, that are more rugged and more diverse than a normal enterprise product. So we had to build our EP and ES taking into consideration those constraints from a space aspect and also from an environmental aspect. And then we also looked at the capability to allow varied I/O options to be populated into our designs. And when it came to processing powers, we are very clear to provide all the choices available, which are Intel, AMD, or an ARM design. Currently, the EP100 chassis could take either an Intel or an ARM along with a switch on a sled. And then we also know that security is very important in our deployment and also in management, so we had to take that into account. And finally, providing an efficient power and cooling systems that allows for a lowered OpEx and a more optimized design in general, were all the key considerations that we took into account for our modular design. So when it came to the flexible I/O and the space that we discussed, as you see on these slides and the pictures that we show here about the EP100 and the ES200, these are short chassis, and these have sleds that support the different processing capabilities and the different switches that we allow and the accelerators that we allow. This basically shows you how we have designed these systems. And this slide highlights some of our roadmap of where we see the industry moving, and thereby we have a roadmap of products that matches with what we believe would be the requirements of an edge customer. And currently we have the 3U EP100, which is available now, and we will have a 1U sled, which is a CLX based 1U sled, available in Q1 of 2020, somewhere between Q1 and Q2 of 2020. And we are also projecting a CLX 2U sled that will be available in Q3 of 2020. And we have a 1U sled, which is an eMag 32 core, 16 core design, or an ORAN or a RIC IEC sled, which will be available somewhere in between Q2 and Q3 of 2020 as well. So, now that we have seen about the edge, let's take a detour into the security and control management. The security and control management is a very key concept that we believe is going to be an important pillar in modularity. So the security and control management, what you see here, basically contains all the software elements, all the firmware elements put together in one board. And it also contains the security element, if need be, if a customer requires extra additional security, that is also contained in this board. And how is this different from the normal unified motherboard is that this breaks the motherboard into two pieces. One where the motherboard, processor, and the memory complex is contained, and then that interfaces with a standard interface into this SCM, which is the security and control management board. And because of this breakdown from a unified motherboard, what we believe is possible is this particular module can be kept constant and could plug into various different configurations. And the various different configurations on the other end could either be different processor architecture boards or different processor socket boards, or in some cases, not even be a processor. It could be a power management controller, or a chassis management controller, or it could be a rack management controller. So there is a lot of variations and different combinations and configurations that this particular SCM could enable. And we are working very closely with several of our customers in enabling this concept in our next generation. And we would be presenting about this in the OCP in several forums as well. While the SCM is specific to the compute platforms that we have designed, we don't necessarily see that it is restricted, like I said before, just to compute. We do see that the same SCM concept can be applied to an OAI concept as well. So we are working very closely with CMAC of Microsoft, and Hope Huang of Wiwynn is working with CMAC to present this concept, how we can extend the same SCM concept to a OAI world. And what you see here is an initial rendition of what the system will look like with an SCM in that OAI system. So another key building block that we see in the set of building blocks is about rack level liquid cooling. And when it comes to rack, there is the ORV3 rack that we are starting to participate and actively work in OCP with several of our customers. And here we do see that there is a possibility and a potential to cool up to 33 kilowatts with a fan design that could plug in as another building block to the rack itself. And these elements that we are building will be compatible with EIA rack, which is the standard 19-inch rack, or the ORV2 rack. Again, extending the concept of building block, so enabling multiple different configurations with multiple different pieces of blocks that are already there in the ecosystem. And then we are also working on a blind mate liquid cooling interface that has been specifically implemented in this solution. And this working prototype is will be deployed in Q3 of 2020. In Yang and Albert Lee of our thermal engineering team are going to be presenting this topic in another session in the current OCP. So now switching gears slightly away from hardware to firmware. So it's not just about hardware. When we talk about modular design, it's not just about hardware. We do understand that firmware is a very important component of the solution. And if we do not build the firmware to be modular as well, then the whole point of building modularity into these designs will be defeated. So knowing that importance of firmware, we are working very closely on two different forums. One is OSF, the Open System Firmware, and the other one is OpenBMC. And we have both of these concepts that we are working with key customers, and we will be demoing and we will be also sharing our experiences of implementing and working on both of these two important firmware threads, which I believe is a key part of achieving modular designs. Jonathan Zhang of Facebook is closely working with Johnny Lin from Wiwynn, and we will be presenting these concepts in other sessions at this OCP as well. And along with these, we would also have a live demo of 5G. This is very exciting for us because this is where the rubber hits the road, where we are taking our design, the EP100 3U 5-node platform, and running actual applications on 5G. This, I believe, will show in motion and in reality what kind of applications can be loaded on this versatile platform, as we discussed before. And some of the speeches, I just wanted to highlight some of the speeches that Wiwynn team will be presenting in this OCP. Please make time to attend and learn, and also give us your feedback on these presentations. The OSF will be presented by Johnny Lin, co-presented with Facebook, Jonathan Zhang. Servers will be presented by Book Kao, co-presented with Microsoft, Priya from Microsoft. Telco and Edge will be presented by Gregory, and co-presented with WNC, Wiwynn or Wistron Network Group, Cheerco. And OAI will be presented by Hope Huang from Wiwynn, co-presented with Microsoft, CMAC. And ACS, which is the standalone rack-level liquid cooling solution that Wiwynn has built, will be presented by Albert Lee and co-presented with Facebook in Hang. So with that, I would like to summarize what we're doing as a company around modularity and how we are building designs. We truly believe that what we have here is an architecture that can be scaled across from cloud to edge. And we are very excited to be part of OCP and having an opportunity to be presenting all of these concepts, exciting concepts. And we are thankful to OCP for giving us this opportunity and also creating this virtual environment where we have a forum to present our ideas and also receive feedback from you. Thank you. Thank you.
Wiwynn, your best choice for workload optimization and TCO.
Hello, is there any questions from the audience? Okay, there was one question that was asked. The question is, with the growing interest in Edge, do you see the industry trying to push ORV3 to align with Edge requirements? To answer that, it's still in the early stages. We are seeing some alignment there, but I would say it's still very early in the game for ORV3 to be aligned with Edge. The other question that I see here is, are there any difference between a cloud server and an edge server in reliability point of view? No, actually not. From a reliability standpoint, we don't see any difference. Actually, an edge server, in some respects, like I said, might have to be more rugged, which means the environmental conditions into which the edge server goes is much more the temperatures need to be higher than a normal edge server, so it actually needs to be much more reliable from that aspect. So I don't see any difference between, certainly not going down when it comes to an edge server. Okay, thank you all for coming, and have a great day.